Hi students, good morning. Welcome back to our physics classes. Today I start with a question. Rubber and steel. You have familiar with two materials, rubber and steel. My question is, which one is more elastic? Rubber or steel? Which one you feel more elastic? Obviously your answer is rubber. I can hear some of you are saying rubber is more elastic than steel. Reason when I ask, some of you can say that when we are stretching, rubber can be easily stretched and steel is tough to stretch. So rubber is more elastic than steel. That may be your answer for me, my question. So we will talk about this matter during this chapter, and this chapter deals with the property of a solid substance, elasticity, property of solid substances, and it is called elasticity. Now we are starting with a new concept in physics, new branch in physics, which is dealing with the properties of matter, You know different states of matter. Matter is present in different states, and in different states, matter shows different properties. And during this, coming two or three more chapters, we deals with properties of matter in different states. Properties of matter in different states. So we will start with the property of matter in the solid state. And we are focusing on the properties of solid material, a particular property called elasticity. So we are going to start with elasticity. So what do you mean by elasticity? Before going to the definition of elasticity, you have to be familiar with the two kinds of forces. And you know, by the property of solids, if you are having a solid substance, it has its own shape and size. Most probably that shape and size is definite, and when you are applying a force on it, it will not change its shape or size. Suppose you are having a duster, and I can show you. So here I am having a duster, and this is a solid material. Obviously, it is a solid material. I am applying a force on it. Its shape is not changing, its size is not changing. So that is one of the property of solid material. It has a definite shape and definite size. And sometimes, suppose you are having a eraser with you. Sometimes you are having an eraser with you. It's a solid substance. It has a definite shape and definite size. But when you are squeezing it, you can find that its shape is changing. Suppose you are having a rubber band with you. It's a solid substance. And if you are applying a force, it can be stretched. Suppose you are having a spring with your hands, and that spring is a solid material. You can compress it very easily. So there are some materials, when you are applying a force, sometimes its shape changes, sometimes its size changes, sometimes both are changing. So that kind of materials, or that property, or that force, I already told you how to familiar with the two kinds of forces. And that kind of forces which can change the shape, size, or both of a solid substance is known as a deforming force. It is known as a deforming force. Why it is called a deforming force? Because it makes any kind of deformation to that solid substance. Either in its shape, or in its size, or in both. Anyhow, a deformation is the result when you are applying such a force. That kind of force is known as deforming force. Okay, suppose you are having that spring which is compressed by a force, and that compressing force applied by you is a deforming force. slowly you are releasing your fingers, what will happen? It will come back to its initial length. Isn't it? Yes. So, whenever that deforming force is released, or when you are removing that deforming force, then what will happen to such a system? It will retain its own initial state. It will retain in its own initial state. For that, what it requires? For that, it requires another force. And that force is acting opposite to your deforming applied force. Isn't it? You are compressing and you are applying a force to compress it, to elongate or to remove that compression. It should be experienced by another force which is acting opposite to the applied force. And what is the property of that particular force? That particular force restores its initial form. When a rubber is fused, its shape changes. When it is released, it will come back to its initial form. So, any force which opposes the deformation, from where that force comes within that system itself, within that substance itself. Such a force generated within a system against any kind of deformation, which tries to restore its initial state, that force is known as restoring force. That is known as restoring force. So, we have two kinds of forces now. One is the deforming force, and the other is restoring force. You can say that restoring force will be generated when it gets deformed. When a system gets deformed, then only restoring force generates. Which means deforming force you can take it as a cause. When a deformation happens, restoring force will be generated as an effect. So, deforming force and restoring force, between restoring force and deforming force and restoring force, there is a cause-effect relationship. There is a cause-effect relationship. Because without any deformation, restoring force will not be generated. Without any deformation, restoring force will not generate. So, whenever there is a restoring force, whenever you feel a restoring force within a system, make sure that or be sure that a deforming force is experienced by that system externally, applied force, externally applied force. So this is an applied force. Which is an applied force? Deforming force is an externally applied force, and restoring force is internal generated force. Internally is in bracket. It's an applied force in bracket externally. Externally, you are applying a force to deform, then a force is generated within the system internally. That is the restoring force. And so, when a deforming force is acting on a system, it undergoes a deformation. And that deformation can be in its length, maybe in its volume, maybe in its shape. So, depending upon the nature of deformation happening, the cause for that and the effect, that means effect is the deformation and the cause is the deforming force. Technically, these two we are expressing as stress and strain. So stress is the cause and strain is the effect. Stress is the cause and strain is the effect. And the stress is defined as deforming force per unit area. Deforming force acting per unit area is stress. And strain is defined as change in parameter divided by original parameter. Change in parameter divided by original parameter. I already told you deformation can be in its maybe in its length. So strain can be defined as change in length by original length, or it is in the shape, change in shape divided by original shape, and whether it is in the volume, change in volume divided by original volume. That is the strain. Change in parameter divided by the original parameter. That is strain. So stress is deforming force acting per unit area, or deforming force when deforming force is generated, applied, restoring force is generated. So it is either in the form of deforming force acting per unit area or restoring force generated per unit area. Stress. You can define stress in terms of deforming force or restoring force. Deforming force applied per unit area or the restoring force generated per unit area. Strain is change in parameter by original parameter. Change in parameter by original parameter. So that is stress and strain. So that is stress and strain. And Robert Hooke, a scientist called Robert Hooke, he studied about the relation between stress and strain. And he found that when the strain is small, that means deformation is very small, stress proportional to strain. Stress applied is directly proportional to the strain, provided strain is very small. And when the strain is very small, that is known as the elastic limit. That is known as the elastic limit. So stress and strain is proportional when the strain is very small. So stress by strain is known as a constant. Stress by strain is a constant and it is known as modulus of elasticity. Modulus of elasticity. So stress by strain is called modulus of elasticity. What is elasticity? Elasticity is the property by which a system opposes the deformation. And even though a system gets deformed under the deforming force, and when you are removing the deforming force, the system comes back to its original initial form. That property is called elasticity. So elasticity, with respect to elasticity, this strain is an important term. Obviously stress is of course, but the strain is more important in the sense strain is the effect caused by stress, applied force. So as in the case of a rubber band, when you are stretching it, it will be elongated, and if you are releasing that force, it will come back to its initial form. And when you are compressing a spring, and when you are removing that compressing force, then it will extend to its initial length. So that is elasticity. That means elasticity is a property by which a system opposes any kind of deformation. The system undergo deformation in the presence of an external deforming force, and when the deforming force is removed, the system comes back to its initial form. That property is known as elasticity. So a system which is reluctant or very, very resistant to deformation, that kind of system is more elastic. If you have a system and that system is more resistant towards any kind of deformation, then that system will be more elastic. Now you think rubber or steel, which will be more elastic? Rubber can be easily deformed and it is easily deform with the help of even a very small deforming force. And steel is very reluctant or very resistant towards the deformation, which means steel is more elastic than rubber, which means steel is opposing any kind of deformation. That means a strong restoring force will be generated within steel than in the case of rubber. That is why steel is more elastic than rubber. So that is the property of elasticity. Based on, we can say that which one is more reluctant to or more resistant to any kind of deformation, and which is tough to be deformed or which is easy to be deformed. If a system is easy to be deformed, then that kind of a system is less elastic, and when a system which is very resistant towards its deformation or it is tough to deform, that system will be more elastic. So elasticity, that is opposite to our conventional thinking strategy, because we are saying that if it is easily stretchable, we are saying that that is elastic. But in physics, elasticity is the property by which a system opposes any kind of deformation. Okay, so remember that. So again, this is known as Hooke's law. This is known as Hooke's law. So Hooke's law says that within elastic limit, stress by strain is a constant. Elastic limit means strain will be small. Under minimum strain or under less strain, stress by strain is a constant, and that constant is known as modulus of elasticity. And this statement is given by Robert Hooke, and it is known as Hooke's law. Hooke's law says that within the elastic limit, stress to strain is a constant. Ratio between stress and strain is a constant, and that constant is known as modulus of elasticity. I already told you there are three kinds of deformation. Deformation may occur in its length, shape, or volume. So now we are not saying deformation. That term deformation we replaced by strain. So deforming force we are replaced by stress, and the deformation we replaced by strain. So we can say that there are three kinds of strain, and each strain is the effect of corresponding stress. So we have three sets of stress strain combination. We are having three sets of stress strain combination, and we have seen that stress by strain is a constant, and if you are having three sets of stress strain combination, you will have three constants also. The ratio stress by strain will be a constant, and we are getting three constants, and these three constants are called moduli of elasticity. So we are having three modulus of elasticity, and we have to see which are these moduli of elasticity and how they can be defined. So first modulus of elasticity. Suppose you are having a rubber wire, a rubber band, and its original length is L. And suppose you are attaching a weight at its end. What will happen? Since it is rubber, it will get elongation. So it is elongated by small l. So you can say that suppose the cross section area is A and the weight mg is acting downwards. So we can say that this mg, the weight, is the deforming force, and elongation L is the deformation happened. So now you can define the stress. What is stress? Mg divided by A, which is equal to simply F by A. Is it? It is simply F by A. Force, deforming force per unit area, that is the stress. And what is strain here? Strain is L divided by capital L. Change in length by original length. change. I already told you strain is defined as changing parameter divided by original parameter. Which parameter is changing here? Length is changing here. So it is changing length by original length. This is strain. Now you think in which direction this stress and strain are acting. Stress is acting along the length. Stress is acting along the length and the length increases. So since the stress and strain are acting lengthwise, this can be taken as longitudinal stress and longitudinal strain. Is it lengthwise? That is known as longitudinal. Longitudinal means lengthwise. So longitudinal stress and longitudinal strain. There you can define one modulus of elasticity, that is longitudinal stress by longitudinal strain, which is known as Young's modulus, and denoted by capital Y. So Young's modulus is defined as longitudinal stress to longitudinal strain. So Y is equal to F by A divided by L by capital L. That is F into L divided by A into L. Fl divided by AL. So this is the Young's modulus. Longitudinal stress to longitudinal strain. That is defined as the Young's modulus Y, which is in which the stress and strain are acting lengthwise of a system. That is longitudinal stress and longitudinal strain, and the ratio is the Young's modulus. Now, if you have a suppose you have a eraser in the form of a cube, and it has 6 faces, and from 6 faces normal forces are acting, and 2 more forces are there. 6 faces normal forces are acting. Normal force is pressure. So when pressure is exerted from all the sides on this cube, rubber cube, what will happen? Its volume will decrease. So its volume changes. So strain is there in its volume. So the volume strain you can define as delta V by V with a negative sign, because it is decreasing. So minus delta V by V is the volume strain. For volume strain, what is the reason? The reason will be volume stress. What is the volume stress here? Normal force acting per unit area. Normal force acting per unit area is the pressure. So volume stress is pressure. So between this volume stress and volume strain, you can define another modulus of elasticity. That is volume stress to volume strain. Volume stress to volume strain. What is volume stress? P divided by minus delta V by V. That is minus PV by delta V. That is the volume stress to volume strain, and it is known as bulk modulus. Why it is termed bulk modulus? Because volume means the bulk of a system. So it is denoted by capital V. That is the second modulus of elasticity, bulk modulus, which is the ratio of volume stress to volume strain. And it is denoted by capital B. That is the second modulus of elasticity. Now, one more modulus of elasticity is there, and that modulus of elasticity depending upon the shape of the system, shape of an object. Suppose on a table you are having a thick book. You are having a thick book placed. Okay, and you are applying a force tangential to its upper surface. You are applying a force tangential to its upper surface. What will happen to that book? You can see that that book is undergoing a shape change. Initially, it was like this, but the shape is changing like this. When you are applying the force tangentially, its upper surface only move forward, and the lower surface are kept at the same place itself, making an angle theta here, which can be measured as the shape change. That shape change occurred, you can measure as theta. So here the shape is changed by a force. Shape change is also a deformation. So shape change also a strain. So the strain produced can be measured as theta. Strain produced can be measured as theta. And what kind of strain is the strain is in its shape. So the shape, strain in shape is known as shear. Strain in shape is known as shear. So this is known as shearing strain. Shearing strain is measured as theta. If there is a shearing strain, what is the cause? Cause will be shearing stress. Shearing stress. Actually, what is this shearing stress? Shearing stress is the tangential force acting. Shearing stress is the tangential force acting. Tangential force acting per unit area. Tangential stress is always force per area. So here, shearing stress means tangential force acting per unit area. Tangential force acting per unit area. So we can say that it is F by A, the tangential stress divided by theta. That is F by A theta. This is the ratio between shearing stress to shearing strain. That is shearing stress to shearing strain, which is obtained as F by A theta. F by A theta, which is known as the rigidity modulus. Rigidity modulus, and it is denoted by eta. This is eta. This symbol is eta. So eta is rigidity modulus, which is a ratio between shearing stress to shearing strain, which is the ratio between shearing stress to shearing strain. So these are the three moduli of elasticity: Y, B, and eta. Y, B, and eta. Y is the Young's modulus, which is the ratio between longitudinal stress to longitudinal strain. Beta is the bulk modulus. It is the ratio between volume stress to volume strain. And eta is the rigidity modulus, which is the ratio between shearing stress to shearing strain. So that are the three moduli of elasticity. And elasticity is the property by which a system opposes any kind of deformation. When deforming force is acting, it undergo deformation. When it is removed, it will come back to its initial state. So that is the property of elasticity, and we have defined Hooke's law and three moduli of elasticity. So that's all for today, and we will meet in the next class.